In regularization, in any machine learning model, a lot of the features will be useless or redundant. Why? Well, that's because we don't know which one is working, which one is important, right? We just throw them all in. That's the beauty of machine learning, is that you don't have to know exactly what is the minimum set of features. You just throw in as many features as you can think of that might be relevant, but not necessarily, and let the machine learning algorithm pick. So because of this paradigm of using machine learning to select features, many of the features are necessarily redundant and useless. Useless is okay, it means it's not predicted, but redundant means there's they are very similar to another feature. So there are two features that are very similar. Maybe 1 day and 2 day return, they are very similar. Maybe 5 day and 7 day volatility. If you use both of them as a feature, they are one of them likely to be somewhat redundant, right? But we don't know which one is redundant, so we throw them all in. If you are going to use all these features, force the model to use all these features as predictors, it will probably decrease bias of the model, but you are likely going to increase the variance of the model. Now, does anyone here not know what bias versus variance mean in the context of machine learning? Please raise your hand. What does bias versus variance mean in the context of machine learning? Okay, I think, there's someone. Okay, thank you. So bias is the error of the prediction algorithm in the training set, and variance is the error in the test set or the validation set, right? So variance is the error out of sample, and bias is the error in sample. So obviously, you want to decrease variance. But sometimes, if your model is, if your model is overfitted, typically you will have very low bias, but very large variance. Good in sample and bad out of sample. On the other hand, if your model is underfitted, that is, you're using too few predictors, then most likely the bias will also be large. So oftentimes there's a way to see if your machine learning model has just the right amount of fitting, is to plot the curve, bias and variance together on the same chart on the y-axis, and with the x-axis, some tuning parameter, maybe the number of features, maybe the degree of regularization, right? That's on topic, degree of regularization. As you increase the strength of regularization, you will increase the bias, but hopefully you will decrease the variance as well. So by regularization is a procedure to eliminate features that does not decrease variance. In other words, to get rid of redundant features. And so typically is accomplished by adding a penalty term to the number of variables. If you have too many variables, this penalty will be large. And so by tuning this penalty term, and here is a hyperparameter, warning sign. This is a hyperparameter to be optimized in the validation set. This penalty will, by adjusting it, you will be able to tune the bias versus the variance of your classifier. You want to tune this penalty to an optimal point such that the variance stops decreasing. And that's when you stop. And again, this variance is measured, of course, in the validation set, not the test set and not the training set. So that's, again, why we need the validation set, is to tune this regularization penalty. So for in more concrete terms, what is this penalty? Well, for linear regression or logistic regression, there is this L1 regularization. There are several kinds. L1 regularization is simply saying that the penalty term is here. Let me use the laser pointer. The penalty term is just the penalty strength times the sum of the absolute value of the coefficients, the regression coefficients. Simple. It's called L1 because the absolute value to the power 1 is L1 norm in mathematics. It's an L1 norm. So that's L1 regularization, oftentimes called lasso. There's another way to do it. It's called L2 regularization, and simply the penalty term is simply the strength of the penalty times the square, the sum of squares of this regression coefficient. It's called L2 because this is the sum of square is L2 norm in mathematics. And sometimes this method is called ridge regression. And then finally, you can combine the two. You know, that's more penalty the better, right? So you can have L1 plus L2 regularization. So the penalty term is this plus this. And this L1 and L2 regularization is often called elastic net. Now, I can never remember these terms, lasso, ridge regression, or elastic net. I complained about that on Twitter a few months ago, that I can never remember them. I only can remember L1, L2, and L1 plus L2. And I get over 1,000 likes for that one tweet. Apparently, that struck a nerve in the machine learning community. There are people far outside of finance come to my Twitter feed and say, like, they also cannot remember these terms. So it's a terrible terminology, but so be it. We need to still have some familiarity with them because many textbooks use them and many software